Okay, ladies and gentlemen, let's take a look at an example of using equating derivatives for finding power functions. Well, first things first, we already know what a power function is. The standard power function is as follows. P of x equals c sub 0 x to the 0, c sub 1 x to the first, yada, yada, yada. Now, this is expanded around 0. If I want a p to the x, but I want to expand it around something else, okay? If I want to expand it around 1, around x equals 1, I need to solve for 0, so I end up with x minus 1. So now it's c sub 0, x minus 1, c sub to the 0, plus c sub 1, x minus 1 to the first, plus c sub 2, x minus 1 to the second, plus c sub 3, x minus 1 to the third. Not entirely shocking. It's just if it's not expanded around 0, we have to turn it into the solution into a factor. So x equals 1 turns into x minus 1. Now, using that as our jumping off point, let's find some derivatives. We already know that c sub 0 would equal p sub, well, in our case, instead of 0, so if we're expanding around 1, c sub 1 is going to equal p sub 1. C sub 0 is equal to p of 0, p of 1, I'm sorry. C sub 1 equals p prime of 1. C2 equals p double prime of 1 over 2 factorial. So we're going to put 1s in instead. And to do that, so we have c sub 0, c sub 1, 2 factorial c2, 3 factorial c3, 4 factorial c4, and that's our standard pattern that we established previously. What I need is I need to take the function and actually derivate it. F of x is natural log of x, so the derivative is 1 over x. The second derivative is negative 1 over x squared. Third derivative of natural log x is third derivative would be 2 over x cubed. Fourth derivative is going to be negative 6 over x to the fourth. Well, if I'm expanding about 1, I take and I say natural log of 1, 0. 1 over 1, 1. Negative 1 over 1 squared. And I get negative 1. Now, in this case, you get negative 1. And so when I solve this, I come over here and I say 2 factorial c2 equals negative 1. So I'm going to divide by 2 factorial. And when I do that, I get c2 equals negative 1/2. Now, when I do this, I have 3 factorial c3 equals 2. So let's go over here, and I have 2, and I take divided by 3 factorial, 3, 2, 1. The 2's cancel out. I'm left with c3 equals 1/3. 4 factorial c4 equals negative 6. When I plug in the 1, I go over here and I say divide by 4 factorial, 4, 3, 2, 1. And we come up with, hey, 6 and 3 and 2 cancel out, so we're left with negative 1/4. That allows us to write the following. P of x minus 1 is going to be the first term, which is c sub 0. Well, c sub 0 is 0 times x minus 1 to the 0 plus we have c1. Well, c1 was 1 times x minus 1 to the first plus negative 1/2, that's c2 times x minus 1 squared plus c3. c3 equals 1/3 x minus 1 cubed plus negative 1/4, because that's c4, x minus 1 to the fourth. So by equating derivatives and using the power pattern to say, hey, c sub 0, c1, 2 factorial c2, 3 factorial c3, we can create this as the expansion of natural log x around x equals 1. And the answer that they gave us to begin to prove against is right up here. Well, since this term is going to disappear, I have x minus 1 to the first. I have negative 1/2 x minus 1 squared, 1/3 x minus 1 cubed, negative 1/4 x minus 1 to the fourth. And so I have now proven that the expansion of natural log x expanded around x equals 1, which was given as this, is indeed truly that. So that's using the equating of derivatives to find the power function.